Hi all, Kevin here. I know it's been quite a while since I made my last video. There's two reasons. One, I was investing a lot of time in one of my other collections, but more about that later when I post a video about that other collection. And two, I did try to make two other tutorials. One for the kit mix-up. In the beginning it was going pretty well. But then my battery died of my camera. After I recharged it, it was too dark, so I had to continue filming a few days later, and then everything went wrong. I had to I redid the solve 3 times, and it was just a complete mess. So I decided not to upload it. In addition, a few hours ago I tried to do a tutorial for the Clover Cube that has just recently been released for fairy puzzles, and the first two solves that I did were a lot easier than this tutorial solve, so that also was kind of failure. So yeah, now I was kind of looking for just a quick video, just so you have something, and I decided why not do a cuboid. So this is the 2x3x3. The basic cuboid, and today we'll do a tutorial on this cuboid. If you can solve this, you can also solve a 3x4x4 or a 3x6x6, and you also have quite a good chance at the even layout cuboids, but 3x2x-n. But today the 2x3x3. I believe this is a Len that I bought from Lightake a few years back, and well, the turning is pretty good. But yeah, not much more to say. I'll just scramble it. Cuboids are, not very hard in my opinion. At least these ones aren't. There are a lot of different types of cuboids. You have these n by n plus p cuboids, like this one. 2x3x3, 3x3x4, etc. You have brick cuboids like the 3x4x5 or the 2x3x4. Those are a bit harder. You also have ultimate shape-shifting cuboids like the 2x4x6. I mean, those are pretty hard in my honest opinion. You also have floppy cuboids like the 2x2x4 or 3x3x5. And well, there are a lot of different type of cuboids, but this one is basically the base. So yeah, let's solve this one today. We'll start by solving all the corners on one side. So let's just do the right side. We have a white corner here, so let's just match it up with one of the others. I see the red one here, so I'll put it here, so it's matched up. Then we'll do another corner. What you want to do here is first put one of the corners in its incorrect place, like this. So if it would be like this, so all solved except for this one. You want to put the corner at this incorrect place. Then you want to put this one kitty corner at the bottom, so you can match these two up. And then you can just simply insert it, put it at the top. So now we have these corners solved. Now we'll do the same for these two. You have two situations. You either have two corners that are next to each other that need to swap, like in this case, these two are solved, these two need to swap. When you have this, you put them at the bottom back. So right here. You do the following algorithm: to R, to F, D prime, to F, D, to R, D prime, to F, D, to R, and then finally U prime. And as you can see, it has swapped the corners. All the corners are solved now. Let me also quickly show you which algorithm you need when there are kitty corner of each other. So they have to swap like this, which is to R, to U, to F, U, to R, to U, F, U prime, to R, to U, to F, U prime. And as you can see, it has swapped these two corners. They were already solved, but so I'll just swap it again. So to put it back really quickly. So yeah, those are the two algorithms, either next to each other or kitty corner of each other. Now that we've solved all the corners, we're going to solve all the edges. So let's start with the right side again. We want the following algorithm will put the piece from here to here. So for example, this white orange one, we put it at the back and it will go to here. And you use the following algorithm for that: to R, to F, to R, to U, and again to F, to R, to F, to R. And well, you put it back where it was. You align the corners again. So I'll see this white one here, the blue. Again, we want to put it here, so we'll put this one at the top back. To R, to F, to R, to U, to R, to F, to R, and we'll put it back. Next is red one. Again, it has to go here. To R, to F, to R, to U, to R, to F, to R. And the final one. So now all the bottom layer is completely solved and the corners of the top layer are solved. So all that's left are these three corners. Edges, I mean, sorry. And this is actually a perfect case for this tutorial, because you can have two cases. You either have to swap, you have two algorithms, I mean. You either have an algorithm to swap two opposites of each other or two next to each other. And with the situation like this, I'll have to do both algorithms. So I'll first swap these two, which will solve the red one, and then I will swap these two to solve the last two. So to swap two opposite corners at the front and back, we simply use this algorithm: to R, to U, 3 times. So again, to R, to U, to R, to U. Simple as that. These two are swapped and the red one is solved. And to swap to adjacent ones, we put them at the front and the right of the top layer, and we'll use the following algorithm: to R, U, to R, U, to R, to U, to R, to U, to R, U, to R, U prime, and to R. And that's it. That's basically how you solve the 2x3x3 cuboid. I realize this is a pretty short tutorial. I will try to do some of the harder tutorials later again. But as I said, I have spent a lot of time on my other collection, and the last two tutorials for the gate mix-up and the clover cube were just a complete failure. So yeah, that's basically it. Thank you all for watching, and I hope to see you next time. Goodbye.